this video, I will talk about one sample test. I will talk about 4 different one sample tests. The first one tests for population mean when population variance is known. Number 2 tests for population mean when population variance is unknown. Number 3 tests for population standard deviation. And finally, number 4 are tests for population proportion. Right? So I'll talk about each of these in turn. Right? So let's start with the first one. Number 1, suppose you have data, say x1 to xm, assumed to be random sample. Remember, random sample means it's the same as saying IID, independent and identically distributed, according to a normal distribution with mean mu and variance sigma squared, where I'm going to assume that the variance sigma squared is known. Right. So this is the case where we are trying to test for the population mean when the population variance is known. Right. Okay. Now I will consider three different tests. The first one is where the population mean is equal to a pre-specified constant v0 versus the alternative that is not equal to mu0. In this case, the rejection rule for rejecting the null hypothesis is if root of n divided by sigma times this is greater than z 1 minus alpha by 2. Remember, this is the percentile of the standard normal distribution we talked about in an earlier video. Referred to as percentiles, right? So this is the rule for rejecting the null hypothesis when you have this as the null and this as the alternative, right? Here x bar is the sample mean, n is the sample size, sigma is the population standard deviation, mu0 is the given value, and alpha is the significance level, right? Usually people take alpha to be equal to 0.05 or 5%. All right, and the second set of hypotheses is this. Right here, the alternative hypothesis is different from this. You are testing that the population mean is greater than mu0, and the corresponding rejection rule is this one. Okay. And the third This is the here. The alternative is that the population mean is less than the pre-specified mu0, and the corresponding rejection rule is this one. Okay. Now, if you ask me where these rules comes from, that's beyond the scope of this course. In year 2, in semester 2 of year 2, you will take a course called Statistical Methods. In that course, you will learn how to actually derive these rejection rules, right? That's a year 2, semester 2 course, right? I mean, for the moment, you don't need to know how to derive them. You just need to know how to apply these rules for a practical problem. And I will do several examples later on. All right, so that's number one. Number 2, here we're going to talk about tests. Excuse me. Right, so it's testing for population mean, and population variance is unknown. So here we're going to suppose that we have a data x1 to xn, which are IID from a normal population with mean mu variance sigma squared, where the population variance sigma squared is unknown. So we are testing for population mean mu when sigma squared, the population variance, is unknown. So once again, I will write down the three different tests. The first one being testing that the population mean equal to a pre-specified constant versus is not equal to. Right. In this case, the rejection rule is this. Right here, S is the sample standard deviation. I mentioned this in one of my previous videos, I think more than once. N is the sample size, X bar is the sample mean. This is specified by the null hypothesis. And this one is the percentile of the t distribution with n-1 degree of freedom. And once again, in a previous video, I showed you how to read these values from a table. Right? All right, so that's for the first set of hypotheses. For the second, this is the rule for the second set of hypotheses, where the alternative is that the population mean is greater. And for the third, it should be 1 minus alpha. Sorry guys, because it should be 1 minus alpha here too. Okay, so these are the three rejection rules corresponding to the three sets of hypotheses, right? And once again, if you have forgotten what S is, I will write it down. This S is known as the sample standard deviation. Right? And is given by the following formula. Okay, so this completes the case of testing for population mean when the population variance is unknown. Okay, and number 3, I'm going to consider testing for population standard deviation. So here I'm going to suppose that you have data which are IID, from a normal distribution with parameters mu and sigma squared, right? So here I'm going to test for, remember sigma represents the population standard deviation and sigma squared represents the population variance. So the tests over here are going to be about sigma. Alright, so here we are testing that sigma is equal to a constant versus it's not equal to the constant. So you reject this hypothesis if the following is true. Right. So here n in this expression n you know is a sample size, s squared is a sample variance, sigma 0 squared is specified by this, and these two guys are the percentiles of a chi-square distribution. I talked about this in a previous video on percentiles. If you look at that video, I'll show you. It shows you how to read values of this from a table. All right. The next right? So the alternative is this, right? Then the corresponding rejection rule is this, right? And and finally, if the alternative is sigma less than sigma 0, then the corresponding rejection rule is this. Right? So this completes the test for population standard deviation. And in the last kind of test, I want to talk about testing for population proportion. Okay. So here we are. So this is number 4. Is test for So here we're gonna suppose that you have data which are IID, from a Bernoulli population. So, for example, if you want to test the proportion of smokers in the UK is less than half, right? So less than 50%, right? Then the data that you will have is each data will be whether the person smokes or not. It's like a 0 or 1. So 0 if he doesn't smoke, 1 if he smokes. As you know, a Bernoulli distribution takes exactly two different values, 0 or 1. 1 with probability p, 0 with probability 1 minus p. So alright, so once again there are three sets of hypotheses I'm going to consider. So here we are testing whether the proportion is equal to a pre-specified constant versus it's not equal to. So in this case we will reject X0 if the following is true. So n is the sample size, x bar is the sample proportion, in other words, the average of these values. P0 is given, and this is the percentile of the standard normal distribution, right? And finally, so these are the three rules corresponding to the three sets of hypotheses. So this completes the video on one sample testing, and in the next video I shall talk about two sample testing. In other words, when you have two samples from two different populations and you want to compare their characteristics, right? How can you do the testing?